Okay, so we're starting with section 1.2 and motion, and we're looking at the basic definitions and application of the formula. We're not looking at the graphs of the motion in the revision worksheet too. So 1.2 motion, and this one I would say is basic. By basic, I mean just definitions and formulae, basic application of the formula. Definitions plus formulae. So this is what we're looking at in this worksheet. Okay, we have 12 definitions to remember, and all of these 12 definitions are really, really important because they come as it is in the exam. Uh, Distance. What is distance? Well, the total length of the distance, the total length of the path traveled by an object. Path traveled by an object or a mass or anything is called the distance. For example, you move from path A and you take this path and you end up at point B. You take this path and total length of the path is, let's say, 18 kilometers. Then the distance would be 18 kilometers. On the other hand, by the way, distance is a scalar quantity. This is something you should know. Distance is a scalar quantity. I'll tell you each one, whether each one is a scalar quantity or a vector quantity. So distance, to begin with, is a scalar quantity. Displacement is the straight line distance between 2 points. Straight line distance between 2 points, and it has a direction. So this one is a vector quantity. Right. Now, because we had distance and displacement, accordingly we have speed and velocity. The speed has to do with the distance and velocity has to do with the displacement. A way to define speed is the rate of change of distance. That's the way we define speed, rate of change of distance, while on the other hand, rate of change of distance, right? And this one is a scalar quantity. While velocity would be I'm just going to copy up the same thing. Instead of distance, I'll put is the rate of change of displacement. So make sure that you're not making a mistake here. It is the rate of change of displacement. And again, it's a vector quantity. Vector quantity, and the one above is a scalar quantity. Next we have is average speed. Average speed is total distance divided by total time. Total distance divided by total time. Okay, this formula for average speed is equal to, you put total distance on top and you would put total time at the bottom, and that's how you would get the average speed. Average speed again is a scalar quantity. Average velocity. So average velocity would be exact same thing, but the difference is instead of speed, now instead of distance, now you will have total displacement. I'm going to copy of the same thing, but I'll make slight changes. And that is, instead of distance, now you will have displacement. Total displacement divided by total time. And instead of distance, you will have displacement over here. And of course, it is a vector quantity. Acceleration. Acceleration is the rate of change of velocity. So either speeding up or slowing down. Acceleration is the rate of change of velocity. Or you can also define acceleration as change in velocity per unit time. Change in velocity, a change of velocity per unit time. This can also work. And acceleration is a vector quantity. Again, cool. Now we have different types of accelerations. For example, we have uniform acceleration, and uniform acceleration is whenever there is a equal change in displacement and Equal change in velocity in equal change in time. So whenever there is equal change in velocity in equal interval of time, right? Non-uniform acceleration would be the opposite, right? So instead of equal, now you will have unequal change of change in velocity in equal interval of time. The time interval would remain the same, but the change in velocity would now be different. So this would be unequal change in velocity in equal interval of time. Okay, for example, let's say time changes from 0, 1, 2, 3, 4, and if the velocity is 0, 2, 4, 6, 8, let's say this is velocity, then you can notice the change. The change is time interval is the same, right? Time interval is the equal. It's +1, +1, +1, and +1. If you look at the change in velocity, is also equal. +2, +2, +2, and +2. That will be uniform acceleration. But if the same pattern follows for, let's say I'm going to draw another table in which velocity, let's say, starts at 0, right? Let's say velocity starts at 0, and then it turns into 1, and then it turns into 3, and then it turns into 6, and it turns into 10, right? There is an increase in velocity, but if you notice, the change in velocity is the change in +1, then there is +2, then there is +3, then there is +4. So do you see the unequal change in velocity in equal interval of time? All right, this is called non-uniform acceleration. What is deceleration? Deceleration, you can define deceleration as negative acceleration or negative acceleration, or you can define it like um, a decrease in velocity, rate of decrease in velocity. Whenever velocity changes in a way that it slows down, it's called deceleration. I'm gonna say it's slowing down. Okay, now we have the two different types of deceleration, uniform deceleration and non-uniform deceleration. The definition is going to be exactly the same. Whenever there is uh, I'll copy the definition from uniform acceleration into uniform deceleration, but I'll change a few things, and that is equal decrease in velocity. Okay. And in this case, it's non-uniform acceleration will be unequal decrease in velocity. Okay, these are two things I will change. For non-uniform acceleration, I would say unequal decrease in velocity in equal interval of time. Right, and I have the formula for acceleration over here as well. And we know that acceleration is equal to v minus u divided by t, where v is the final velocity, u is the initial velocity, and of course t is equal to time taken, while a is equal to acceleration. These are a few definitions that we need to know, and I think let's start. A student measures the speed of the trolley. At one instant, the speed of the trolley is 1 meters per second. So initial speed is 1. 2 seconds later, so time is equal to 2. The speed is 4 meters per second. So final speed is 4. What is the acceleration? We know that acceleration equals v minus u divided by t. V would be 4. U would be 1 divided by t. 4 is going to be 3 over 2, which is going to be 1.5 meter per second square. And hence, meter per second square, and A would be your answer. Which vehicle has an acceleration of 5 meters per second square? Let's see. A bicycle, when it speeds from rest means that the formula I'm going to use over here is v minus u divided by t. In this case, acceleration will be equal to a rest. This is the initial speed. This is the final speed, this is the time, right? So 2.5 minus 0 divided by 2. 2.5 divided by 2 will be equal to 1.25. That's definitely not 5, so I'm going to cross out A. A car, when it changes its speed from rest, so which means the initial velocity is 0, right? So, and final velocity is 15. So 15 minus 0, final minus initial, divided by 5, which is going to be 15 divided by 5, which is going to be 3 meters per second square, which is definitely not it. We're looking for 5. So I'm going to cross out B as well. A lorry, when it changes speed from rest to 20 meters per second in 15 seconds. So which means final speed is 20, initial speed is 0 divided by 15. That is going to be 20 by 15. Also, I don't think that's 3. 20 divided by 15 would be, you can work it out. I don't think it's 5. 20 divided by 15, that would be 1.33, which is definitely not 5. So I'm going to cross out this one. Of course, the answer is going to be D because that's the only option left. But let's see. Uh, from rest to 50 meters per second, which means final velocity is 50. Initial velocity is 0 divided by 10. 50 divided by 10 will be equal to 5 meter per second square, and hence D is your answer because we were looking for 5 meter per second square velocity. An object moves from P to Q in 10 seconds with uniform acceleration. Velocity at P is equal to 5 meter per second. Velocity at Q is 12, and the time it took was 10 seconds. So let's work it out. Acceleration will be equal to V minus U by T. V is the final velocity, which is 12. Initial velocity is 5 divided by 10. 12 minus 5 would be 12 minus 5, that's going to be 7. 7 divided by 10 will be equal to 0.7 meter per second square, and B is your answer. Next, a car begins to move. It speeds up until it reaches a constant speed. Okay, it continues to travel at this constant speed for the rest of the journey. What happens to the acceleration? What happens to the velocity of the car during the journey? Right? So a car begins to move, right? Which means begins to move. Initially, it was at rest. Okay, then it accelerates, right? And reaches, for example, this is point A, reaches point B. From A to B, it accelerates, right? Until it reaches a constant speed. And from B onwards, it moves at constant speed and goes on and on. What happens to the acceleration? Did acceleration change? Of course, acceleration was over here. Acceleration had a certain value, right? Over here, acceleration, initially the acceleration was, let's say, 5 meter per second because the car did accelerate, right? When it says speeds up, which means the car accelerates. And when the speed is constant, the acceleration is equal to 0. So yes, acceleration did change from a certain value to 0. When the car is moving at a constant speed, that's when the acceleration is 0. So the acceleration changes, yes. What about the velocity? Initially, it was at rest, so velocity was equal to 0, right? And then it started moving at a constant speed, so velocity has some value. Let's say, 10 meter per second. For example, I'm taking any random number. So acceleration changed, yes. Did velocity changed? Yes. Only acceleration changes would be incorrect. Only velocity changes would be incorrect. None of them changes would also be incorrect because the both of them actually changed. Acceleration also went from, actually, you can think about it this way. Acceleration went from a certain value to 0, while velocities went from a certain value to velocity went from 0 to a fixed value. Okay. Next, a lorry takes 15 minutes to travel along the path PQRS. What is the average speed? So how do we work out the average speed? Uh, Average speed is equal to total distance over total time. That's average speed. Right. What is the total distance? 8, 9, 10, 11, 12, 13, 14, 15, 16. The total distance is 16 kilometers. So total distance is 16 kilometers. Right. Time. Let's take a look at time very carefully. If you look at the answer, all of the answers contain the time in hours, right? For R, R, and R, right? While I'm given time in 15 minutes. So I hope you know 15 minutes. If you do 15 divided by 60 to convert this into hours, you are going to get 0.25 hours. Okay, so time is equal to 0.25 hours. 16 divided by, you're allowed to use a calculator, by the way. 16 divided by 2.25 is 64 kilometers per hour. So the answer is going to be D. A car accelerates at 5 meter per second square. So we're given the acceleration is equal to 5 along a straight horizontal road and reaches a terminal velocity of 20 meter per second. Reaches a velocity of 20 meter per second in a time of 4 seconds. During this time, the total displacement is 40 meters. Which quantity is scalar? Okay. Acceleration is a vector quantity. Velocity is a vector quantity. Displacement is a vector quantity. Time is a scalar quantity. So B would be your answer. A cricket ball has a mass of 0.16 kilograms and it hits a bat with a speed of 25 meters per second. After being in contact with the bat for 0.013 seconds, the ball rebounds with a speed of 22 meters per second in the direction exactly opposite to its original direction. State the difference between speed and velocity. It's a one marker question to make sure you're not writing more than a single sentence. You can say, well, velocity has a direction because you can say velocity is a vector quantity while speed is scalar. That's it. Keep it simple. Right. Let's move on to part B. Okay. Calculate the change in the velocity of the cricket ball. Now look at it very, very carefully. We know the velocity is a vector quantity, right? Velocity is a vector quantity, which means it has a direction, right? And we take direction as in terms of if it's moving in this direction, for example, towards the right, the direction is taken positive, but if moving the other way around, if moving towards the left, direction will be taken, the sign will be taken as negative because we know that it's the opposite direction, right? If you look at it carefully, a cricket ball of mass has a mass 0.16 and hits the bat with the speed of 25 meter per second. So initially, when it came, it had a speed of I would say initial speed of 25, right? But when it was hit back, the final speed was 22, 22. So if you notice, the direction would now is now the opposite, right? This is why I will put a negative over here. Okay, negative 22. Why did I put a negative over here? Because this is a scalar quantity, and scalar quantity has direction. And if I have to represent that the ball is moving in the opposite direction, I will put a negative over here. This negative over here represents the direction. Represents opposite direction. Okay. So how do you calculate the change in velocity? Well, we know the change in velocity is v minus u. V will very carefully put negative 22, which is the final velocity, minus 25. So this answer is going to be negative 47 meters per second. Make sure you put a negative over here. Otherwise, your answer will not be marked as correct. The average acceleration of the ball while is in contact. Well, we know that A equals V minus U divided by T. We already calculated V minus U, which is negative 47. And time in this case is 0.0013. 0.0013. So 47 divided by 0.0013, that is going to be -3,36,153, -3,6,153.8 46 meter per second square. Make sure you do it this way, otherwise it'll be regarded as incorrect. Okay, this negative is very, very important. If you notice, this is negative, which means the acceleration is negative, which means this is deceleration. And it makes sense. How is it deceleration? Because there is a decrease in velocity. If you notice, the initial velocity is 25, but the final velocity is 22. So there is, in fact, a decrease in velocity, right? Slowing down, and hence negative acceleration. Or we saw these definitions above. What is meant by uniform deceleration? Uniform deceleration is equal decrease in velocity in equal interval of time. Okay, because this is uniform and hence there is an equal. And because this is deceleration, I'll say decrease in velocity. What is meant by uniform acceleration? Of course, equal equal change in, we saw all of these definitions above, equal change in velocity in equal interval of time, or you can say per unit time. They will both make sense. Equal in equal change in velocity in equal interval of time, and that is uniform acceleration. Okay, a ball rolls down a slope as shown in figure 1.1. So here's a slope, right? Here's a slope of you can say a meter rule, right? The meter rule shows the position of the ball at time t is equal to 0. So this is where it starts from. Time t is equal to 0. Time t is equal to 1 second. If you notice, between the first second, it only traveled a distance of 10 meters. Okay, so if I were to make a table, um, I'll help you make a table to better understand this distance. At time is equal to 0, the distance was 10. I mean, this is where it started from. When time was equal to 1, when time was 1, the distance was when time was 1, the distance was 20, right? When time was 2, the distance was 50. The time is 3, the distance is 100. Right? If you carefully, very, very carefully notice, the body traveled only 10 meters in the first second. Then it traveled from 20 to 50 would be, it traveled 30 meters in the next second. And it traveled 50 meters in the third second. So if you notice, the ball is speeding up, right? Initially, the speed was slow, but actually the ball is traveling faster and faster. Does it make sense? So what is happening to the ball? The ball is accelerating because it's covering increasing distance in the equal. The time interval stays the same, right? Uh, this is 1 second. This is also 1 second. This is also 1 second. The time stays the same, but the amount of distance traveled in the same amount of time is different, right? So how the figure 1.1 shows the ball is accelerating, how would you show that? Well, we can see the ball is accelerating because it covers increasing distance in equal interval of time. The time interval is not changed. Time interval stays from 0 to 1, then 1 to 2, 2, and 2 to 3. The time interval does not change, but the amount of distance traveled in each interval is, I'll show you over here. If you notice, time interval does not change. This is +1, 1 to 2 is +1, 2 to 3 is +1. But if you look at the distance, 10 to 20 is +10, but 20 to 50 is +30, 50 to 100 is +50, right? So if you notice, the distance is increasing. There's this increasing distance traveled in equal interval of time. Calculate the average speed. I don't think average speed should be a problem. We know that average speed is equal to total distance divided by total time. What's the total distance? Well, you started off at 10, right? And you ended up at 100, which means 100 minus 10 would be 90. Please do not write the distance as 100. The distance is 90 because this is where you started from, 10, and this is where you ended at 100. This is the end, right? So 100 minus 10 would be 90 centimeters. Okay. So make sure that you're putting in the right units. Distance is 90 centimeters, and total time is 3 seconds because you went from 1 to 3. So this is going to be 30. Now write down the units very, very carefully. 30 centimeter per second. Because in this case, the amount of distance traveled is in centimeters and not in meters. So this is 30 centimeters per second. Very, very, very careful with the units. State radius meant by velocity. This is pretty simple. Rate of change of displacement. We just saw that a while ago. Okay. A car of mass 800 kilograms is traveling at a speed of 25 meters per second along a straight horizontal road. How velocity differs from speed? We just saw this question a while ago. I would say velocity is vector. That's enough. A driver presses accelerator and the speed of the car starts to increase from 25 meters per second from 25 meters per second. So from 25 meters per second, which means the initial speed was 25. The car accelerates at 1.5, so acceleration is 1.5. Time taken was 4 seconds. Determine the speed of the car after, which means we're looking for the final velocity, right? We know that A equals V minus U divided by T. Acceleration is 1.5 equals, we're looking for final velocity. Initial velocity is 25 divided by 1.5. In fact, time is equal to 4, right? So I'll multiply 4 over to this side. 1.5 multiplied by 4 equals V minus 25. This is going to be 6 equals V minus 25. If you move 25 over to this side, this would become 6 plus 25. And speed will now be equal to 29 meters per second. This is a classic application of the formula. A skier sets up from rest and accelerates uniformly. Rest means initial velocity is equal to 0. Accelerates uniformly at 3.4, straight line for 5 seconds. So time is equal to 5. Calculate the speed of the skier after 4 seconds, which means we're looking for the final velocity. Again, initial velocity equals U is equal to 0, right? A equals 3.4, time equals 5. We're looking for final velocity because we're looking for the speed after 5 seconds. So I'll put this in the formula, V minus U divided by T. In this case, V is, we need to find out V. U is 0, time is 5, and acceleration in this case is 3.4. So 3.4 times 5 would be 17, right? So 17 equals, in fact, I'll do it step by step. 3.5, this 5, when it goes over to the side, it gets multiplied. So 3.4 multiplied by 5 equals V minus 0. V minus 0 is just 0, V, and this is going to be 17. So the answer will be 17 meters per second. A car accelerates from rest in a straight line. During the first 14 seconds, the acceleration is uniform and car reaches a speed of 25 meters per second. Right, so initial velocity is 0, time is equal to 14, and final velocity equals 25. We need to find out the acceleration. We know that it's V minus U by T. V is 25 divided by 0, minus 0 divided by 14. 25 divided by 14. That is going to be 1.25 divided by 14. That is going to be 1.785 meter per second square. I'm gonna say this is the acceleration. I am hoping it makes sense. Let's do this one. A cyclist travels along a straight horizontal road as shown in figure 1.1. How the average speed of the cyclist can be measured? This is a very, very important question. So this includes basically the topic one, which is physical quantities and measurement, right? We just saw topic 1.1, physical quantities and measurement. It includes the concept from topic 1.2, which is motion. Let's do it very, very carefully. A cyclist travels along a straight horizontal road as shown in figure 1.1, how the average speed of the cyclist can be measured. In your account, suggest what equipment can be used and the measurements that are made and how average speed is calculated. Right? So this is 3 marks, and 3 marks is they already gave you the distribution. 1 mark is for the equipment used. Uh, Measurements that are made, number 2, and how average speed is calculated. You'll score the 3rd mark for this one. Right? So how would you? I want to measure the average speed. We know the formula for average speed is equal to total distance over total time. How would you do that? Well, what's the total distance? How would you measure total distance? We do not know what the total distance is. How would you measure it? If you remember, we saw some instruments for measuring length, right? One of them was meter rule, the other one was measuring tape. Because we're measuring large distance, we will use measuring tape, right? So we'll say we will use the measuring tape to measure the amount of distance traveled. And you also have to measure time as well. And how would you? And we'll use stopwatch to measure the amount of time taken. Okay, now you have the distance, and now you have total distance and the total time. Then we'll use the formula. And what's the formula? We know that formula is average speed is equal to total distance over total time. We'll use this formula to measure average speed. That's it. This is for 3 marks. I hope it makes sense, right? So you have to use the right instruments to measure the length, right instrument to measure the time, and take the measurements, and that's that. Uh, Next. Um, For the part of the journey, the cyclist has a constant negative acceleration. What is meant by negative acceleration? Well, a rate of decrease of velocity, right? Or you can say decrease in velocity per unit time, decrease in velocity per unit time. That's negative acceleration. Okay. The size of the acceleration is 1.8 meter per second square, which means acceleration is 1.8. Calculate the change in speed of the cyclist. So basically, formula for acceleration is change in speed over time, right? The thing that we do v minus u, that is actually the change in speed, right, by time. So we need to find out v minus u. Okay. Time is equal to 2.5, and we need to find out just v minus u. Okay, so the formula is A equals V minus U divided by T. Acceleration is 1.5 equals V minus U divided by T. In this case, time is equal to 2.5, right? So V minus U is equal to 1.8 multiplied by 2.5. So if we were to do the multiplication, that is equal to 4.5. Okay, so we only have to work out V minus U. We don't have to work out the value of V or value of U, but we only have to work out the change. So change in speed would be 4.5. Do not forget to put the unit, 4.5 meter per second. State the name given to negative acceleration. We know that it is deceleration. Okay, you know the name. Right. So I hope it makes sense. I hope you got a pretty good idea on the basics, definitions, and using the formula to tackle word to tackle the past paper questions.